So this video is going to be one of two dealing with the principle of excess, which is whenever you use one chemical in quantities that are greater than what is actually needed for doing a chemical reaction. So we need to think about what does it mean. So if you do a chemical reaction, you sometimes add more of a chemical than is needed. Now the reasons for doing this are to make sure that all of the other reactant is completely used up. Now we do this when one of the chemicals is particularly expensive and we want to make sure it's all reacted. We'll use the other chemical in excess. Or if a chemical is particularly dangerous or toxic, we'll use the other chemical reacting with it in excess to make sure that all of that dangerous chemical is removed by the end of the reaction. So whenever we use more than what is needed, it is called an excess. The amount of product you can make is determined by the chemical that is not in excess, because the chemical that's not in excess is going to be completely used up and it's going to determine how much product you can make. That chemical is known as the limiting reactant. So the one you have more of than you need is called excess. The one that you have exactly the right amount to fully react is the limiting reactant, and it determines how much product you can make. So how to work out what is in excess and what is limiting is by calculating the moles of your chemicals and looking at, do those moles fit the mole ratio, and working out what you have versus what you would need. The limiting reactant is the one that's fully used up and limits what can be produced. The other reactants in excess. If a chemical is in excess, some of it will be left over at the end of a reaction. Now there are two types of excess questions. In this video, we're only going to deal with the ones involving gases where we're applying the principle of molar volume. In the follow-up video, we're going to look at molar excess questions, which are the more common one, but you do still need to know excess when it comes to gases. So when it comes to excess questions, regardless which one it is, you need to understand about what you have versus what you need. So whenever you read a question and it tells you the quantities of chemicals that you started with, those numbers are what you have. And when you work out the moles using those numbers, that is what you have. When you take one of the chemicals and apply the molar ratio to it to work out how much of the other chemical would fully react with it, that is telling you how much you need. And if you have more chemical than you need, you're in excess. If you need more chemical than you have, then you're limiting. That's how we work out whether a chemical is in excess or whether it's limiting. So it's always, we need to deal with moles or volumes for gases, and then look at the molar ratio to see, do we have more than we need or need more than we have? So when it comes to our reacting gases, remember if chemicals are gases, they apply to the principle of molar volume, which is if you have the same number of moles, you have the same volume, which means you can apply the molar ratio to the volumes. So we've got a question here. 50 centimeters cubed of carbon monoxide is burned with 20 centimeters cubed of oxygen. Which gas is in excess, and what is the total volume and composition of the resulting gas mixture? That word resulting gas mixture means all the gases that still remain at the end of the process. If a gas is in excess, that means some of it will be in that resulting gas mixture because it didn't all react. So the first thing we need is a balanced equation. Carbon monoxide reacts with oxygen to produce carbon dioxide. Our ratio is 2 to 1, and then we produce 2 of our volume. From the question, we can see what we have. we have 50 centimeters cubed of carbon monoxide, we have 20 centimeters cubed of oxygen, and because it's a product, we don't have any carbon dioxide. To work out what we need, we keep one of the volumes the same and use the molar ratio to work out how much of the other chemical we would need. In general, whichever volume is the smallest, keep that one the same and work out how much of the other one you would need. So in this case, we're going to keep 20 centimeters cubed the same and work out how much carbon monoxide we would need. So we are saying that we need all of that 20 centimeters cubed of oxygen. It is in a 1:2 ratio with the carbon monoxide. So we would need 40 centimeters cubed of carbon monoxide. If we look at the numbers for carbon monoxide, we need 40 and we have 50. We have more than we need, so carbon monoxide is in excess. To answer an excess question, you always need to write a sentence or a statement in your answer explaining why your numbers lead to that conclusion. We need 40 centimeters cubed and we have 50, so it's in excess, or we have more carbon monoxide than we need, so it is in excess. So we've answered part A. We now need to go on and answer part B. What is the total volume and what is the composition of the resulting? So we've got our have, we've got our need. When it comes to resulting, we need to think about the limiting chemical determines what we produce. So we need to think about what will we make in this reaction. So if we are using 20 centimeters cubed of oxygen, it is the chemical, it's our limiting reagent. It's going to tell us how much carbon dioxide we produce. And remember, we do not produce any reactants, we only produce products. And oxygen is in a 1:2 ratio with our carbon dioxide. So if we use 20 oxygen as the limiting reactant, we will make 20 times 2, 40 centimeters cubed of carbon dioxide. The resulting mixture is what you had at the start, take away what you needed to react, add on what you produced. So we had 50, we needed 40, we have 10 carbon monoxide left. We had 20 oxygen and we needed all of that, so there's no oxygen left. We had no carbon dioxide and we produced 40, so we have 40 at the end. Our resulting volume is 50 centimeters cubed and the composition is 10 centimeters cubed of carbon monoxide, 40 centimeters cubed of carbon dioxide. So here's another example. Calculate the volume and composition of the resulting gases when 100 centimeters cubed of propane burns completely in 600 centimeters cubed of oxygen at 20 degrees Celsius. So look through our equation. Everything's a gas, but water, we don't know anything about water. It does not have a state symbol. And this is something that happens frequently in questions about gases where water is involved. And that is because we need to look at the temperature and work out whether water is a gas or a liquid at that temperature, and therefore whether or not we need to involve it in our equations or not. You're expected to know that water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. So at 20, water would be a liquid, which means it's not a gas, it's not going to be involved here. So at 20 degrees, it's not a gas, so we just use the ratio for everything that is a gas. From the question, we write down what we have, 100 of propane, 600 of oxygen, and then what we do, we take our small number, our 100, use the mole ratio to work out how much we would need of the other chemical. So if we need all of that 100 and it's 1 to 5, we would need 500 oxygen. Now this is where we need to work out which one is limiting, which one is in excess. Well, we have more oxygen than we need, so oxygen is in excess. We use our limiting one to determine what we produce. So our limiting one is our propane. We have 100 of it, and a 1 to 3 ratio means that we will make or produce 300 carbon dioxide. The resulting mixture is what you had minus what you needed, add what you produced. So we'll have no propane left over, we'll have 100 oxygen left over, and we made 300 carbon dioxide. So we have 400 centimeters cubed. 100 of that is oxygen, 300 of that is carbon dioxide if you're asked for the composition. Now, would this be different at 200 degrees? It would, because at 200 degrees, water is now a gas, and so would need to be involved in our equations. So this time we use our mole ratio, including water this time. We start off again with what we have from the question. What we need does not change. Propane is still our limiting reactant. Oxygen is still in excess because we have 600 and we only need 500. And that means we're going to use that 100 propane to determine how much carbon dioxide and how much water we would produce, which is 300 carbon dioxide and 400 water. In total, 700. So at the end, resulting, no propane left over, 100 oxygen left over, 300 carbon dioxide produced, 400 water vapor produced, giving us a total of 800 centimeters cubed, which makes a big difference to our total volume. So that has been what is excess and applying it to gas situations. In the next video, we'll look at how we apply excess where we have to calculate the number of moles.